Hello and welcome to the QA Therapy podcast. Are you looking to improve your overall testing and quality practices? My name is Sergio Freire and I'm a solution architect and a testing advocate at Xray.
And my name is Cristiano Cunha, and I'm also a solution architect and test advocate. And we'll be your hosts and QA therapists throughout this series. In this podcast, we're going to tackle some of the most common testing and quality challenges that we all face in our teams. So if this sounds good to you, keep on listening.
Have you ever heard about keyword-driven frameworks? Or test automation tools that are low-code or no-code? Is there something in between? Can we have a tool or framework that can assist us in making test automation scripts in an easy way yet flexible one? Well, to assist us with this topic, we have a special guest with us, Pekka Klark. But before introducing him and welcoming him, let's see what it's really bringing you here. What are the symptoms that you may have been feeling that has brought you to listen to this podcast? So, do you or your team lack automation skills but still want to implement some test automation scripts? Do you wish to implement test automation that goes beyond traditional web UI automation? Or even, do you feel that certain parts of your automation code are repetitive and wish you could easily abstract them? Do you wish to be able to implement several layers of abstraction from your test automation code? Or do you wish to have an automation tool that is easy to use and yet easy to extend? Or even do you feel it will be great if there were already some existing code blocks that you could reuse for your test automation scripts without you having to know the specifics of that particular protocol, interface, or other aspect?
All these are symptoms that maybe you have or have not ever tried a keyword-driven testing framework. Maybe you have tried to big and complex tools that promise great automation capabilities or others that are just too simple and that don't address your needs and that usually fail on customization capabilities. Let's dive a bit into this topic. And today we have here with us Pekka Klark, our expert QA therapist, to assist on diagnosis and prescription on these symptoms related to test automation. Pekka was the creator of Robot Framework and works together with the Robot Framework Foundation to improve Robot Framework and its ecosystem. Welcome, Pekka. Are you comfortable on our QA therapy couch?
Thanks. I hope to be able to help at least with robot framework and topics related to that. And great to be here.
Awesome. So let's start with a first, let's historical kind of question. Why and how was Robot Framework born for the newcomers that don't know about it?
So why it was created? Well, I started my career in testing and in test automation right after the millennium in 2000, and got somehow hooked with test automation from the very beginning. And was creating different kind of test automation solution in very different kind of projects. And at sometime there, I also kind of realized, okay, I may need to. It would be a good idea for me to graduate from the university, and I needed a subject to study for my master's thesis. And I decided to study test automation frameworks, more precisely keyword-driven frameworks and data-driven frameworks. I had noticed while implementing that kind of frameworks for various projects that there's kind of a lot of similarities, and I'm often writing similar kind of loggers and similar kind of a parser for the test data. And I was thinking that there might be something reusable there. So that was kind of the research idea that, okay, let's see what kind of common components could be created. And interestingly enough, then after the prototypes that I created, it came clear that we could actually have totally generic keyword-driven framework that wasn't only like some kind of components that you could use, but instead the core itself would be totally generic and could be reused. And that was how it got started. That was basically the concept. But then the next step in the history was that a colleague of mine, Petri Haapio, was working for Nokia Networks, and they needed automation solution there. We had worked together with him in some other automation project earlier, and there was some kind of success there. But when he contacted me and asked, "Do I have ideas how to, what kind of solution would work in their case?" I proposed my kind of these latest ideas I had studied, and they got interested. And
when we talk about robot framework, usually we hear about acceptance testing, and keyword driven is things that comes to mind. So can you tell us a bit more about these two aspects, this ATDD and KDT?
If you start from keyword driven testing, that's absolutely not a new invention. So that's been available for a long time. I read about that quite early in my career, and that I had to kind of when I was writing some early automation frameworks, I knew about that, and some of the frameworks I created were kind of keyword driven, and then I studied it more and more in my master's thesis. Keyword driven testing basically is just that you construct your test cases from keywords, and keyword is something that it does something. And then some frameworks separate keywords that are doing something, like action, and keywords that are validating something, but I don't consider that so important. For example, with robot framework, when you build a test case from keywords, you just use a keyword, and some of them are doing something to the system, and others are then validating it, and so on. So that's what you do. So it's kind of a really simple programming language, in a sense that you have blocks that are kind of Lego blocks that you construct, and you can mix and match them. So with different kind of keywords, you can create different kind of test cases without knowing programming that well, because although it's kind of programming, it's very simple compared to kind of real programming languages. So that's what keyword driven testing is. Acceptance test driven development then is basically just a way to form requirements. Although it has test in its name, it's more about requirements gathering. Typically, people are more familiar with behavior driven development, which I consider as one way to do ATDD. But kind of the idea there is that we create automated test cases, or examples, as people typically want to call them, before starting the implementation, and then as part of the implementation, we also add needed glue code and tooling so that we can make those test cases pass. Robot framework and keyword-driven frameworks in general work very well in this kind of approach, because they typically allow you to make test cases, to write test cases, the top-level test cases, without having the implementation ready. So the high-level test case typically isn't tied to implementation, like, for example, with record and playback tool or something like that, where you cannot have anything done before the system is there. You can write the description, this is how we want it to behave, even when the system isn't there yet. Then, of course, you may need to refine that when the system is actually implemented. But at least the high level you can write just fine.
One question related with coding. How much coding do I need to know to use robot framework? Can I just use it out of the box with some existing libraries tailored for some specific purpose without having to code, or do I need to code?
I guess that depends on your definition of coding. I would actually say that also when creating test cases with robot framework, you kind of are coding. Then, of course, the language is simple, so it's not that complicated. And learning the simple kind of way to construct robot framework test cases should be very easy. As I said, it's kind of building stuff from Lego blocks, basically.
Yeah. So, but I don't need to know, let's say, Python in order to
No,
use
you
robot
don't need to
framework,
know.
right?
You don't need to know any kind of real programming language like that. But of course, you then need to learn robot framework syntax. And with robot framework syntax, the simple things like how you construct your test cases are very simple. It's just basically those keywords and the possible arguments for those keywords. Then things can also, on robot framework level, can get more complicated if you want to. Because one of the strong features in robot framework is abstractions. So actual implementation So the things that actually are doing something for the system that you are testing or automating otherwise, that's always in a library. So there's always a library that is implementing using a kind of a real proper programming language, which typically is Python in robot case. So you implement libraries in Python, and then they are actually interacting with the system. But then on robot framework level, you can create higher level keywords. So if your keywords in the library are really low level, like on a level of clicking a link or clicking a button, you may, and of course, typically also should then create kind of abstraction levels that are more domain specific, like log in or send invoice or something like that, and not talk about kind of interface terms. So that kind of keywords you can create in robot framework syntax. And that's also kind of programming. You basically are creating new keywords that's kind of creating macros. Again, still relatively easy, but you need to know the syntax to be able to do that. But that's something that is also for non-technical people, based on my experience from running dozens or hundreds of robot framework training courses, very easy to learn. The really strong point of robot framework is, though, that you can very easily then go from those robot framework syntax to real programming language to Python. So that's one of the key features in robot framework. The library API is.
So for the beginners, what are the main concepts in robot framework?
Robot framework data test cases are created in files using robot framework's own syntax with .robot extension. That's just plain text files, so it works very well with version control system and so on. So no need to have robot framework plugin for Git or anything like that. It just works. So that's where you get your test case files, and a file containing test case in robot framework is automatically a test suite. So that's how you create a suite or set of test cases. In robot framework we call them suites, but well, that's the same thing as test set in some other terminology. You can also put those files into a directory, and then when that directory automatically creates a higher level test suite. So you can have a directory with some test case files, and then you have like nested test suite structure very easily. And because it's just files and directories, it still works very well in version control system. In those files, then you can import libraries, and libraries are typically then Python code, and they are developed as Python modules and installed using normal Python installation mechanism. And well, that's how they behave. You can also, you can have more generic libraries, typically bigger libraries that you actually install. They can also, there's a big ecosystem around robot framework. I think we probably want to talk about that separately. But anyway, there's a big ecosystem, so you can install those ready-made libraries and use them. Also, if you create your own, you don't necessarily need to install them. You can basically have them next to your test case files and just use them directly. But anyway, that's Python code. Those are libraries. Another key component there on data level basically is that you can have so-called resource files where you can have higher level keywords in robot's own syntax that I was just talking about a bit earlier. And they are then using other possibly other higher level keywords or these library keywords from imported libraries. So they are also plain text file in robot framework syntax, but the different concept and the test case file, because they don't contain tests, they only contain keywords and possibly some variables and imports and so on. So those are the concepts on robot framework side. Then of course, when we have a library, the library can communicate with the system that you are testing, which is of course very important big piece of the puzzle here. So the system that you are testing is probably most important for you. The library that you have, it can communicate with the system directly, or it can use some external tool for that. For example, for web testing, you probably don't want to implement a new web testing tool for yourself. You want to use something like Selenium or Playwright in your library. And in robot framework case, in this ecosystem that I just mentioned, we have ready-made libraries for both for Selenium and for Playwright.
So Pekka, I think the keyword concept in robot is like something really relevant because it presents this layer of abstraction. You also mentioned that you can have keywords that are composed of other keywords to have an additional layer of abstraction, correct?
Yes. So that's a
And
key thing. Having this high-level keyword syntax in robot framework is a key for making it possible to have generic libraries that can be created so that basically everybody can use. Because, for example, for web testing, if you have your own application there, you want to be using domain-specific keywords in your test cases. But if they are domain-specific, they are not then something that someone else could use. But you can have lower level keyword that is talking with interface terms, buttons, links, stuff like that. And that then everybody can use. And then this robot framework keyword syntax allows you to create your own domain specific language on top of that. But that's you don't need to use those high level keywords though. If you want, you can just have the high level description in robot framework syntax and then everything else in Python. So that's also an option, which can be a really good option if you have a lot of Python programmers there that are more comfortable writing Python than robot framework code.
so let's say that I install Robot, and actually I have Robot, but let's say our listeners install Robot. What kind of automation features they have out of the box right away?
One is that what libraries we have when you install robot framework. There are certain
Yeah.
so-called standard libraries that you get with robot framework. For example, library for processing XML files or for string processes and stuff like that. We haven't been adding
That comes
standard
out of the
libraries.
box.
Yeah, they work out of the box. We haven't been adding many of those lately simply because Python packaging is nowadays working much better than it was working like 10 or 20 years ago. And it's kind of easier if libraries are external libraries because then they can be developed outside the robot framework core and they can be released on their own kind of schedule and so on. So that we may be adding more kind of built-in stuff to robot framework. That's if there's something that makes sense. But I believe that we in the future more and more have this library as an external dependency so that you install robot framework, and then if you are doing web testing, then you install a library for web testing, and if you are doing database testing, you install a library for database testing and so on. So it's unlikely that robot framework standard library collection will get that much bigger in the future. So that's one thing. Another thing was this, you asked about this syntax. So that's definitely true that robot framework has nowadays. It actually has quite a lot of syntax, kind of programmatic syntax as well. That's relatively new addition. Robot framework has had for loops and kind of ways to do conditional execution like if and else for a long time, but it was only like two years ago or something like that when we started adding more and more actual programmatic syntax to robot framework data so that you can now have if proper like if and else structures, even exception handling like try except stuff and while loops in addition to for loops that we already had it earlier. So we've been adding that kind of syntax there as well. It makes robot framework syntax more and more like a programming language, of course, but still you don't need to use those, and most of the time you shouldn't use them on top level test cases. It's kind of get awkward if your test case is very, very complicated, and also if you have a lot of if structures on your test case top main level, then it's kind of unclear what you actually are testing. But these constructs can be very helpful on lower level when implementing keywords and when you need to take certain things into account. Also, these control structures are very useful when using robot framework for process automation, which is perhaps something we may want to talk separately again as well. But robot framework nowadays, it's not only used for test automation, it's also used for process automation. And there, it's more important to have more control on like conditional logic and handling errors and stuff like that. But yeah, that kind of syntax has been added, and most likely some new syntax will be added still in the future. It's been kind of interesting how the framework has been evolving because the initial concepts for robot framework in my master's thesis and earlier versions, they didn't have anything like that. Everything like that was always like the idea was that, okay, that's done in a library. But there has been concrete needs by the community and we've seen that, okay, it makes sense. And especially in this process automation, RPA, that in that field, these constructs are really, really important. So we've been adding them. it still depends kind of case. You don't need to use them, and it's totally valid to use robot framework also, so that you basically have only the test case in high level there, and then everything below that, all the keywords are implemented in Python, and that's fine as well. But there's so many different kind of ways, different contexts where you can use it. So you can use the level that works best for you.
If you went back in time, I guess the young Pekka from 2005 would be surprised.
Yeah, definitely. It's interesting how the now a lot of our kind of design discussion are more like language design discussion. So I'm for a long time acknowledged that the syntax in robot framework is a programming language in itself. It can be called like low code solution, but definitely it's not no code solution. You can build no code solutions on top of robot framework syntax. You can have visual editors and stuff like that, of course, if you want to. But robot framework syntax itself, I acknowledge that it's a programming language. And there's of course a balance that what we want to do. If it's too simple and too limited, then it's impossible to get things done, and then people need to implement horrible hacks to get bit more complicated things done. But then when we add new syntax, then also it's kind of gets more complicated. So, but I think the balance nowadays is pretty good. I personally, I'm very happy how the new syntax that we've been adding in recent years have turned out, considering that people have had those same needs earlier, and how they've been solved earlier when they needed to do some kind of error handling or conditional logic.
And looking at other testing frameworks out there, many times we see this automation frameworks more focused on web applications, more focused on APIs. But robot framework is more an agnostic kind of tool, right? As you were talking about, it will depend on the libraries beneath. But what kind of systems can you target with robot framework?
Yeah, that's a very good point. I'm actually kind of annoyed when I see a new interesting looking blog post or something like, okay, new automation tools or comparing automation tools, and then I go there and it's just like web testing tools. And like, well, that's you should mention that if you're comparing web testing tools to each other, because you cannot really compare robot framework, for example, with Selenium or something like that, because they're totally different things. So robot framework is a kind of very pure automation framework in the sense that it's not tied to any interface technology. The core framework, if you strip also the standard libraries away from it, actually cannot be used for testing anything, because it cannot interact with any system whatsoever. You always need to do that with libraries. And then the question is, what libraries do we have? Well, we do have plenty. So there are ready-made libraries for web testing, databases, various kind of REST APIs, Windows UIs, Java UIs. We have even libraries for something like SAP and mainframes and that kind of technologies that may not be the most kind of popular or kind of hip tech at the moment, but still there are libraries for those. So a lot of different kind of libraries exist. Also, a very, very important domain for robot framework is embedded devices testing, and that's where you don't that often have ready-made libraries. You often need to implement your own libraries that are somehow interacting with that embedded device that you are developing using whatever interface there you have. But then anyway, that's a very strong field for robot, because there aren't ready-made tools for that domain that much in general. But with robot, if you can create the library, then you get data syntax and logging and all that out of the box from robot. So it's just about creating that library. And Python happens also to be a very good language on that domain, because it can interact with basically anything.
And so when we talk about these tools for testing, we always wonder, how are they tested? Do you use robot framework to test robot framework, or do you use something else?
We absolutely use robot framework for testing robot framework. It kind of would be odd if we wouldn't, kind of eating your dog food and all that. We also have some then low-level test cases that we are that are unit tests. And for unit testing, we use Python standard unit test module. PyTest would be a lot better better choice, but kind of historical reasons why we didn't take it into use. Back in the day, we were supporting Python and also Iron Python, and some early version of Python they didn't support PyTest, so we couldn't use it from the beginning, and we haven't switched afterwards. Nowadays, I think it would be quite we could do that, but there would be just quite a lot of work to change the setup. But most of our test cases, anyway, they are on higher level using Robot Framework. Many of those test cases are kind of integration test or not that much maybe acceptance test cases, but we are kind of using Robot Framework for everything where it can be used, even if it wouldn't necessarily be that good idea in some other scenario. For us, we are kind of taking it into its limits as just a kind of experiment.
Pekka, earlier you mentioned that Robot Framework is not just around testing. Even though it started perhaps more having testing in mind, but it somehow evolved into become more generic automation framework that nowadays also covers our RPA. What are the similarities between test automation and RPA? And why Robot Framework, let's say, can be used to tackle these two different branches?
That's a very good question. There's actually, interestingly, from tool perspective, the differences are very minimal. Basically, there are none. If you think about the tool, it's the same thing. It's just basically interacting with the system and then clicking buttons. So if it's a UI, of course. If it's not the UI, then you are not clicking buttons. But basically, doing things like that and then validating that things went right. And you, of course, when you're doing any kind of automation, you want to know that did that thing that I do succeed. So from tool perspective, there's really not big difference. Actually, interestingly, the RPA support in Robot Framework basically is that in those test case files or suite files where you are defining test cases, you can, if you change one header where it says typically test cases, and under that header you write your tests. If you change that header to tasks, then you can write task under it. But then the syntax for creating those tasks is absolutely 100% same as creating tests. So there's no difference. And the framework, when it's running something, it doesn't know anything about that. Are you running a test or task? The only other thing basically where you see it, that when you get the log afterwards, it says typically test log, but if you are creating tasks, then it says task log. So that's from the tools perspective, there aren't actually differences. But then from mindset perspective, it's totally absolutely different mindset. When you're doing test automation, you want to break things. You want to basically take the system that you are testing into extremes, and you want to try to torture it as much as you want. You want to do all the things that users shouldn't basically be doing, but they could accidentally. So you try to do something like this. Also, when things go wrong, you basically want the test to fail immediately and just report the failure and provide as much information as possible. So that's basically the testing mindset. You want to break it. You want to take it all limits and then just report all the failures. Whereas in process automation, when we are trying to automate something like sending an invoice or some stuff like that, we don't want to take it into extreme. We want to be as careful as we want. We want to consider the system that we are interacting with as as delicate as possible, like having a kind of a very gentle touch and trying to be as polite as possible, and through everything we'll have long waits and whatnot, so that make sure that okay, this should succeed. And if it doesn't succeed, then you most of the time you want to try again, which of course would be unheard of in test automation. No, it didn't work first time. Let's try three more times. Users probably won't be that happy if you say that well it succeeds every 20th time, then that's okay. But then again, if you want to get a task done and it's done automatically, you don't really need to care that much if it succeeds immediately or on the second or third time. You want to retry. You may want to try another API. Like we wanted to first try to do it via REST API. It didn't succeed. Let's try to do it from the user interface. That's not something you want to do in test automation. So mindset when
Yeah.
you're creating those is absolutely different. You want to have error handling in RPA. You want to handle those somehow gracefully.
It's also a good opportunity for people embracing test automation, also having the possibility of embracing RPA by reusing the same knowledge and the same tool set that they are used to, I guess.
So, one last question before we go. The time goes by. How you'll be talking about libraries and contributions. So, how big do you think this community around Road Framework is, and what is the main channels of communication that you guys have out there that can help anyone that may need support with Road Framework?
Um, because it's open source tool, it's impossible to know how many users we have. We can see page views and we can see some download numbers, but download numbers are nowadays kind of to some extent a bit meaningless because often CI systems are downloading same packages multiple times per day, so that kind of inflates those numbers. But well, the community is relatively big. The most active channel at the moment we have is our Slack that you can access. It's just slack.robotframework.org. You go there and then you can get an invite to the Slack community, or if you already are a member, then you can just join in from there. But we have on our Slack, I think it's something like 14,000 members, so it's a really big community there. Another kind of, I don't know, what does it say? But if you look at GitHub stars, it's something like close to 8,000, I guess nowadays, and something like this. But this, it's so hard to tell anything about those numbers because, of course, for example, on our Slack, they are somehow active because they have joined, but of course, not everybody is there talking every time. But it's a very very good community, very friendly, and if you have questions related to Robot Framework, you typically get good answers. We also have a more public forum that you can access as well. We have old email list and there's a LinkedIn group and stuff like that. But yeah, the Slack is nowadays the most active one. You can find all of these if you just go to robotframework.org.
So time flies, and we are now reaching the end of the episode, Pekka. So once again, thanks for being here with us and help us understand a bit more about Robot Framework and this whole amazing ecosystem, and also the vibrant community.
Yeah, it was great being here. If I have still time, I can do a quick ad. I don't know when this podcast is going to be out, but we have a Robocon conference. We had the on-site one in Helsinki in January, and now we are going to have online one in early March. So if this podcast gets out before that and people are interested, then you can go to Robocon.io.
Thank you.
Okay, thank you.
Before ending our episode, it's time for some vitamins. We know that in general they are good for our health. In this case, we'll be talking about vitamin X, where X stands for Xray. With Xray, you can perform acceptance testing or even perform acceptance test-driven development using Robot Framework without ever losing information about your test results in Jira, your single source of truth. Xray provides information on the test results not only at high level, but also at keyword level, giving you the ability to drill down in case your keywords are composed in turn by other keywords. If you use Robot Framework's Linear library or Robot Framework browser library, you may also take screenshots in your UI tests, and then this will become visible in Jira so the team can analyze the test results in finer detail. Whether you start developing a story from scratch and wish to embrace ATDD from the start, or else if you are testing an existing feature, you can use Robot Framework to help build a comprehensive and manageable test suite, and use Xray to track the results and the impacts on the related stories or requirements. With Xray, you may annotate your Robot Framework test cases with the story issue key, for example, to have it automatically linked to it whenever importing the test results. You may also add custom tags to your test cases, and then they will become labels in your test issues, so you can easily find or manage them afterwards. And you may not even need to worry about too much about Jira, because whenever you upload the results, tests are automatically provisioned for you if needed. Focus on adding value. Focus on writing comprehensive and powerful automated test cases with Robot Framework instead.
And as all good things come to an end, also this episode is reaching its end. And we have seen that Robo Framework is a well-known automation-focused framework, highly popular in the test automation space that has more recently also embraced RPA. With Robo Framework, testers can easily create automated test scripts without having to code, taking advantage of the fact that Robo Framework is a keyword-driven framework. Many keywords are either available out of the box, provided by the community as libraries. Skilled testers or developers can further extend Robo Framework to their needs and implement new keywords, for example. But all this is only relevant because of the underlying community, which is quite supportive. So why not give it a try?
So see you in our next therapy session. Happy testing!
Happy testing!